Good morning, everyone. So today we will start real numbers. All right. So this is real number. Well, so this is the first chapter. All right. You just understand the things clearly and come to class. Okay. First, real number. What is real number? Real. Let us understand this first. Uh, First, the natural numbers 1, 2, 3, 4, 5, 6, 7. These are natural numbers, right? These are natural numbers. And if you add 0 to this, then this will be what? Whole numbers. This will be whole numbers, right? These are whole numbers. So if you add 0 is extra in this, right? So natural numbers are also known as counting numbers. These are used for counting. Okay. Then if you add 0 to the whole numbers, natural numbers, you will get whole numbers. Then if you add this negative numbers, if you add this negative numbers to the whole numbers, you will get integers, right? Whole numbers plus the negative integer, negative numbers. Okay, -1, -2, -3, etc. This together are called integers. Then, in addition to this, if you add fractional numbers like 2 by 3, okay, in addition to integers, 2 by 3, -7 by 9, 16 by 4, etc. If you add, then this set of numbers are called rational numbers. Alright, we can define it. How can we define rational number? A number which can be expressed in P by Q form, where P and Q are integers and Q not equal to 0 is a rational number. We'll come back to the definition again, but now let us understand. Irrational number. Which are irrational numbers? Root 2, root 3, root 5, root 7, root 11 are the numbers like this: 0.0200200002, etc. That is, this type of decimals are called non-terminating, non-recurring decimals, right? Non-terminating, non-recurring decimals. This type of decimals are irrational numbers. We got this in class 9, right? So these are irrational numbers. Now what is real number? Real numbers are rational numbers plus irrational numbers. Rational numbers and irrational numbers together are called real numbers. Like the negative integers, we can say this: negative integers, sorry, negative integers, positive integers, fractional numbers, okay, like this, fractional numbers, then irrational numbers like this, together are called real numbers. That is, real number include natural numbers, whole numbers, integers, rationals, irrational numbers, all. Okay, all the numbers, whatever we have learned till today, all together are called real numbers. Is that clear? Okay, let us go to the pictorial representation of this. Now you see, these are natural numbers. Okay, if you add 0, it will be whole number. Then if you add negative numbers to this, then it will be integers. And if you add fractional number to this, then this set will be rational numbers. Then irrational numbers will be this. Which are irrational numbers? Root 2, root 3, root 5, root 7, and this non-terminating, non-recurring decimals like 3.0200200002, 1.13113, okay, 1113. You got this in class 9, irrational numbers, right? Okay, so this all together, if you combine these two sets, okay, if these two sets you combine, you will get real numbers. Clear? These two sets, if you combine, these are real numbers. Okay. So this we have already learned in class. This we have already learned in class 9. Now our main point of discussion is not this. This is the basic. Now our main point of discussion is Euclid division lemma, Euclid's division algorithm, all this. Okay, before going to that, let us see, let us define rational number. Okay, what is the rational number? What is rational numbers? What are rational numbers? Okay, let us see. A number which can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0, is called a rational number. Yes or no? We got this in class 8 itself. For example, a number which can be expressed in P by Q form, like 5 can be written as 5 by 1, 0 can be written as 0 by 1, then 2 by 3, okay, minus 7 by 9. These all are in P by Q form. Hence, they are rational numbers. P by Q form. They are in P by Q form. Okay? They are in P by Q form. So, they are rational numbers. So, I think this is very, very basic. We got this in class 8 itself. And in class 9 also we discussed. Now, irrational number, let us discuss what is the irrational numbers, right? Now, irrational numbers. So, what is irrational? Irrational numbers. Okay, a number which cannot be expressed in P by Q form, where P and Q are integers and Q not equal to 0. A number which cannot be expressed in P by Q form, where P and Q are integers, and Q not equal to 0, is called an irrational number. For example, root 2. You cannot write this in P by Q form. You see, root 2, you may say root 2 can be written as root 2 by 1, but is it integer? Is it integer? Root 2? No, this is not an integer. So this is not a rational number. Okay, so this is not a rational number. Similarly, root 5. Okay, now can you tell me root 4 is rational or irrational? Root 4 is 2. So is it irrational? This is rational. Alright? So this is rational. This we cannot write here. Root 7 is irrational. Similarly, root 10 is irrational. like 2.03003, that is non-terminating, non-recurring decimals, right? This type of decimals are non-terminating, non-recurring, and they are irrational. I think rational and irrational and other numbers, real numbers, rational and irrational together are called real numbers. Okay, all together are real numbers. Okay, then let us go to division lemma. What do you mean by Euclid's division lemma now? Okay, let us understand what is Euclid's division lemma. Euclid's division lemma. Okay, now let us straightway go to problem, division problem. Okay, let us say 11 divided by 3. If you divide 11 by 3, then 3, okay, let me give it, instead of 11, let me give it 13. 3 4s are 12 and 1. This is the remainder, right? This is the quotient. This is called divisor. Okay. This is called dividend. Okay. This is called the remainder. In lower classes we got that dividend is equal to divisor into quotient plus remainder. Did we get this? Did we get this? In class 4 itself we got this, right? Dividend is equal to divisor into quotient plus remainder, right? This fact, here we can write this as, using this, how we can write? Dividend is equal to 13 is equal to, divisor is what? 3, quotient is what? 4, remainder is 1. So the fact, if you write in this way, this is said to be written in Euclid's division lemma. This is so we applied Euclid's division lemma here. What we did? We have applied Euclid's division lemma here. Okay, this way. That means any two positive integers you take. Okay, that means any two positive integers, let a and b be any two positive integers. Then if we divide a by b, you will get some quotient here. Let q be the quotient and r be the remainder, right? Then how we can write? A is equal to, you can write this as okay, A is equal to B into Q plus R, right? B into Q plus R. Can we write like this? This is nothing but dividend is equal to divisor into quotient plus remainder, right? Dividend is equal to divisor into quotient plus remainder. So any two positive integer, if you take any two positive integers a and b, we can always get a quotient and remainder. We can always get a quotient and a remainder which satisfies this property. That is, dividend equal to divisor into quotient plus remainder. This is said to be, this is known as Euclid's division lemma. This is known as Euclid's division lemma. Is this point clear to you? This is known as Euclid's division lemma. Okay, that means any two positive integer, if you take any two, let us take 2 and 6. Let us take 2 and 6. Okay, 2 and 6 if you take. If you divide 6 by 2, you will get two numbers. Here, what you will get? 3 and remainder will be what? 3 to the 6. 3 to the 6, remainder will be 0. So, this is R is equal to 0, Q is equal to 3. So, for any two integers A and B, any two positive integers A and B, you can always get two positive integers Q and R, which satisfies 6 is equal to 2 into Q plus R. That is, A is equal to BQ plus R. This relation is satisfied. So what is this actually? It is actually dividend is equal to divisor into quotient plus remainder. Is this clear? Now if you take, conversely, if you take now here we have taken this as A. If you take this reverse, conversely if you take this conversely, like if 2 is divided by 6, then what happens? If 2 is divided by 6, it will go 0 times 0, 2. So what is the quotient here? Quotient is 0, remainder is 2. Okay, so it is true for any two positive integers, be it small or big, doesn't matter. Okay, so generally we take A is equal to the bigger number and B as the divisor. We always take B as the divisor and A as the dividend. Okay, is this clear? So I think Euclid's division lemma is clear to you. Okay, Euclid's division lemma is clear to you. Now there's a definition. As a definition, how can we write Euclid's division lemma? Now Euclid's division lemma can be defined like this. Okay, we can define this as this one. Okay, look at this. Euclid's division lemma. Given positive integers A and B, there exist unique integers Q and R satisfying A is equal to BQ plus R, where R lies between Q and B. This, what is the meaning of this now? What is the meaning of this now? When a number A is divided by B, okay, quotient is Q and the remainder is R. This is the meaning? Okay, this is the quotient and remainder. This is the meaning or not? This is quotient and this is remainder. And this is nothing but dividend is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. Now, what is the meaning of this? This is the remainder. Remainder is less than the divisor. See, any number, if you divide 13 by 4, okay, 4 3 is 12, remainder. This remainder will be always less than. Remainder will be always less than the divisor or not. Can this number be greater than 4? Can this number be greater than 4? Remainder is less than, always less than divisor. Remainder is always less than the divisor. Okay, when you divide 13 by 4, can the remainder be greater than 4? What is the maximum remainder it can have when you divide a number by 4? When you divide a number by 4, something, if you divide by 4, what can be the remainder? It can be 0, it can be 1, it can be 2 or 3 at the most. These are the possibilities of the remainder, right? So that means it cannot be negative. So that is why it is given greater than 0. Remainder must be greater than or equal to 0, and less than B. The divisor cannot be equal to the remainder. Cannot be equal to the divisor. Can the remainder be equal to 4? No. That is why it is less than B. You understood my point? So if you divide a number by 5, if you divide a number by 5, what can be the possible remainders? Can you tell me? It can be 0, 1, 2, 3, 4. These are the possible remainders. Then if we write this as r, so can we write r is less than 5 and greater than equal to 0? Can we write remainder is less than 5 but greater than or equal to 0? This means less than or equal to. Okay, this symbol means equal. This is less than and this is equal. Alright, so it can be equal to 0. Remainder can be equal to 0, but it must be less than the divisor. Is this point clear? Is this point clear? This is known as Euclid's division lemma. This statement. Okay, this statement. Well, okay, then we have understood Euclid's division lemma. Now we will understand Euclid's division algorithm. We will understand algorithm and lemma first. What is algorithm? An algorithm is a series of well-defined steps. An algorithm is a series of well-defined steps which give procedure for solving a type of problem. Algorithm is a step-by-step procedure to solve something. So if you apply Euclid's division lemma step by step to solve something, then it is called Euclid's algorithm. Okay, what is lemma? Lemma is a proven statement used for proving another statement. Okay, lemma is a proven statement used for proving another statement. It is like a theorem. Okay, lemma is like a theorem. It is a proven statement. Okay, it can be used for proving another statement. Okay, this is about algorithm and lemma. Now we will discuss Euclid's division algorithm. Now let us understand this, then I'll explain. Now Euclid's division algorithm, to obtain HCF of two positive integers, say C and D, with C greater than D, follow the steps below. So apply Euclid's division lemma to C and D. So we find whole numbers Q and R such that C is equal to, okay, these three steps we have to follow. Here it is difficult to understand this way. I'll explain this with example, then it will be clear. So this algorithm is called Euclid's division algorithm. Now if I explain with the example, then it will be clear to you. Okay, look at this. How to find HCF using Euclid's algorithm. Now you see, let us take two examples. Suppose 48 and 15, suppose these two numbers. Okay, A and B. A and B, these two numbers are given. You have to find HCF of these two numbers using Euclid's division algorithm. Now, in class 4, we have got a repeated division method of solving. Finding HCF. Now you see, first what you have to do, by the smaller number you divide the bigger number, 48. Okay, in class 4 you got this method of finding HCF, if you remember. If not, you see how we did. Okay, so if you divide, question you write this side here. Question you write on the right. 15, how many times it will go? 15 3s are 45, right? So what will be the remainder? 3. Okay, now next, by this 3 you divide the previous divisor, 15. How many times it will go? 5 times. 5 3s are 15. When you get remainder 0, you stop. What is given here? You see? What is given here? Apply Euclid's division lemma to C and D. These two numbers are C and D actually. This is C, this number is C, and this is D. Alright. Apply Euclid's division lemma to C and D. Here what we did in this step, first step was, there are two steps are there. What are the two steps? One is 48 divided by 15, that is 3 times, right? 45, remainder is 3. One division. Another is what? Another 15 divided by 3, 5 times. 15, remainder 0. Two steps are there or not? So this will give you what? If you write according to Euclid's division lemma, 48 can be written as dividend is equal to divisor into quotient. Divisor into quotient. Quotient is what? 3 plus remainder. Remainder is what? 3. Right? So, then second step is what? Second step is dividend is equal to dividend is equal to divisor into quotient plus remainder. When you get remainder 0, this is the remainder, right? When you get remainder 0, the last divisor will be the HCF. Last divisor will be the HCF. Last divisor will be the HCF. Now let us look at the algorithm. Okay. Yeah. Apply Euclid's division lemma to C and D. We applied Euclid's division lemma to C and D, and we got this first statement. Okay. Number 1 we got. Then so we find whole numbers Q and R such that C is equal to DQ plus R. This is C equal to DQ plus R. We have applied this here. This state. Okay. So obviously remainder will be less than D and will be greater than or equal to 0. Right. Now if the remainder is 0, you will stop. If the remainder is 0, you will stop. If remainder is not 0, we have to divide again. This is what it is saying. If R is equal to 0, D is the HCF. Had this been 0, 15 would be the HCF. Now since this is not 0, so if R not 0, apply the division lemma to D and R. D and R means what? This is the R, okay, and this is the divisor D, right? So apply the division lemma to D and R. So we apply division lemma to D and R. What is R here? R is this 3 and D is 15. So we applied again. We divided again, right? So we got this statement. According to Euclid's lemma, if you write, you got this statement, right? Now, if you write this much only without looking at this, if this is the gist of this division, yes or no? This is the gist of this division. From the first division, you can write dividend equal to divisor into quotient plus remainder. This way you can write. From the second division, you can write dividend is equal to divisor into quotient plus remainder. So when you get remainder 0, last divisor will be the HCF. Last divisor, this one will be the HCF. Therefore, HCF will be equal to 3. Last divisor. Now here, continue the process till the remainder is 0. The divisor at this stage will be the required HCF. The divisor at this stage means when you get remainder 0, the last divisor will be the HCF. You understood this point? This algorithm works because HCF of C and D is equal to HCF of D and R. That is, HCF of C and D and R will be same. Okay? Yes. Okay. So this is it. So in a nutshell, what we can say? Suppose if you are given two numbers like 25 and suppose 70, these two numbers are given, you have to find the HCF by Euclid's division algorithm. Then what you have to do? By here you have to write, you have to divide this and write the Euclid's lemma here. Again you divide the second divisor. If the remainder is not 0, then you have to divide again. Like for example, this one is saying 70. By the smaller number you have to divide the bigger number. How many times it will go? 2 times 50. Okay. So we'll write this on the right side. 2 times 50. Remainder is 20. So first, okay, by Euclid's division algorithm, by Euclid's division algorithm, 70 is equal to dividend is equal to divisor into quotient plus remainder. First we have written. Then again second what you will do? by this you have to divide. By this you have to divide what? 25. Divisor. How many times it will go? 1 times 20. So remainder is 5. That means what we did, this part. Okay, this part. You write algorithm for this part again. So what you will get? What you will get? 25 is equal. Dividend is equal to divisor. Divisor is what? 20. Question is what? 1. Plus, what is the remainder? 5. Okay, so we have written the algorithm for this. Then again, remainder is not 0. Remainder is not 0. So what we will do? We'll divide again. What will divide? The previous divisor. 20. How many times will go? 4 times. 4 5s are 20. Remainder is 0, right? Now for the third division, what you will do? What you will write? The dividend is equal to 20. Divisor is 5. Quotient is 1. Sorry, quotient is 4. Remainder is 0. You got remainder 0. So the last divisor will be the HCF according to the algorithm. Last divisor will be the HCF. Therefore, what will be the HCF? HCF will be the last divisor. Clear? Is this clear, all of you? Okay. So in the next video, we will find HCF. We'll find HCF and do some more problems related to Euclid's division lemma. Okay. In this video, this much only. So you go through again and again. Wherever you have not understood anything, you can ask me in the class. Okay. Thank you.